In this video, you will learn how to plot a Monte Carlo histogram for bandwidth variance, perform a temperature sweep, and add parasitics to ideal components in PSpice. Let's use a bandpass filter as the example circuit. To perform Monte Carlo analysis, components must have their tolerances specified. In this case, device tolerance is added to the resistor. Here, the temperature coefficients Tc1 and Tc2 have already been entered, as a temperature sweep will be performed in the latter part of this video. Monte Carlo analysis works with any of the three analyses types: AC, DC, or transient. Let's run an AC analysis with the settings as shown. Monte Carlo analysis is set up to run with the AC analysis for the output variable Vout with the total number of runs as 50. Click OK to save the simulation settings. Now run the PSpice simulation. The Available Sections dialog box lists all the 50 Monte Carlo runs as specified in the sweep settings. These waveforms show the variation in the value of output voltage considering the component tolerance that was specified earlier for the load resistor. To plot a histogram, go to the axis settings under Plot and select the Performance Analysis option. This adds another plot for the histogram on the window. Let's plot a histogram to view the results for the 1 dB bandwidth. Click on this icon and add a trace expression for 1 dB bandwidth of output voltage. This plots the Monte Carlo histogram showing the yield for 1 dB bandwidth measurement. The unique feature of performance analysis can also be used to evaluate further behavior of a circuit. As an example, let's plot a graph to see the change in 1 dB bandwidth with respect to temperature. From the simulation settings, uncheck Monte Carlo analysis and select the temperature sweep option. Temperature sweep is set to repeat the simulations at each of the temperatures, 0, 25, 50, and 125 degrees. Let's run the simulation. The above graph shows the variation in 1 dB bandwidth with change in temperature as specified in the settings. Many generic SPICE simulators only allow you to simulate circuits with ideal components, but PSpice allows you to model these selected non-ideal components in your circuit on the fly using the modeling app. Let's replace this 125 nanohenry inductor on the schematic with its non-ideal counterpart. There are certain parameters to consider when modeling non-ideal inductors in PSpice, and they are shown here. These parameters can be obtained from the inductor datasheet, and you can input these same values in the modeling app. Replace the ideal inductor with its non-ideal counterpart. Rerun the PSpice simulation. The simulation goes through successfully, taking into account the inductor parasitic. Now you have successfully learned to plot a Monte Carlo histogram, perform temperature sweep, and add parasitics to ideal components in PSpice.